Two wires side by side, currents flowing free, electricity moving in perfect harmony.
So hello everyone, let's start the experiment itself. So right now we have this setup. Try to choose for the first part, which is basically about changing the current and checking how much force this current loop is exerting on this magnet assembly, and put weight on the scale itself. So I would say choose the long one, the one with the long horizontal line. So in this case I choose the current loop SF41 or 42. So let's basically, we have 0 ampere. Let's turn on the scale. It is 0. If it is not, just press star to be 0. Make sure that the loop does not touch anything, the magnet. Then basically let's start to put the current inside the current loop and increase the amount of current. So now it is 0.5 ampere, and we can see that it went from 0 at 0 ampere to 0.4 grams for 0.5 ampere. Let's increase to 1 ampere. So it becomes 0.6. So what we are going to do right now, that we're increasing 0.5 ampere until we reach 5 amperes. So right now it's 1.5 amperes. Then we have 0.9, right now it is 1.1 grams. Then let's have 2 amperes. You have 2 amperes, it's still 1.1 grams. Sorry, let's continue, but let's open it first. So we need to disconnect the current itself, open. Then we have 0, then we connect again the current. So right now we have 2 amperes and we have 1.4 grams. Let's increase it to 2.5. So we have 2.5 amperes for still 1.4. Let's have it 3 amperes. 3 amperes for 1.7. Then 3.5 for 2.1. Then let's say 4 amperes for 2.4, then 4.5 amperes for 2.8, then 5 amperes, the last one, for 3.2 grams. So basically there's a force that push this magnet assembly on the scale itself. So right now we have finished the part 1, which basically it's about changing the the current going inside the current loop. Now we are going to change the length of the current loop itself. So first we need to disconnect the power supply. After disconnecting the power supply, we need to basically put this one up like this and start to change the current one. But let's start with this one. Let's have the value here 2 amperes. So we have a current of 2 amperes. First let's open the scale, make it 0, then put the current, then basically let's make it 2 amperes, 2 amperes. So it's 2 amperes. We have 1.5 grams. Then let's change this one. Basically we need to turn off the current, then put it up. Let's remove the loop itself, and we put another one. This one is SF38. Let's put it inside. Make sure you are not touching anything with the magnet. So it's 0. Let's input the current of 2 amperes. It's 2 amperes. Right now it's 0.8. We have done this. Let's disconnect the current. It changed the loop itself. Let's have another one. This is SF37. Put it inside. Okay, let's turn on this one. Then let's connect the current. 2 amperes, it's 0.4. Then you need to do this for every single current loop. Okay? Then we go from this. Basically, you record all these values. Let's disconnect. And at this point, we need to change the third part is to change the amount of magnetic field. So in this case, what we are going to start with is basically, let's remove this one. Let's put the one with the longer wire, which basically SF42. And here we put it inside, but we need basically to remove the magnets from the magnet assembly. Put it inside. Then we need to start to add the magnets one by one and basically record the values. So in this case, we need to press star with the scale is 0. Okay. We add one magnet inside, like this, for example. I will show it to you here. So I will have this one. So it is like this. We need to press start to make it 0. Then let's see the current itself. Connect the current. We have 2 amperes. Then we see how much difference. We see it is 0. We have 0 grams. Almost there is nothing. No much force. And at this point, let's disconnect the current. Remove the magnet assembly. Add a new one. Add a new piece of magnet. Permanent magnet. We put it here. Let's put it inside. Let's connect the, let's first press 0, then connect the current. So you can see, in this case, it becomes 0.6. Sounds good. So let's add one more magnet. So we disconnect. We remove this magnet assembly. Add one more magnet. So we have 3 magnets. Put it here. As we said, press star 0. Then let's connect the current. And the current in this case it's 2 amperes. It becomes 0.8. So we keep doing this until we put all the magnets inside. Put a magnet. Disconnect first the current. Put the magnet, 0 the scale, then connect the current, then have the value I recorded. So now let's do the fourth part, which is a force created when you have 2 magnetic fields but with different angles. So basically we need to remove this magnet assembly. We just collect it. I'll put it back. It's not easy because of the repulsion force. So let's store this one. Okay. It's good. Let's have the accessory kit with this one. We disconnected the current. We remove this one. Remove the current loop. Put it back. Let's have this magnet assembly. The star. Let's connect the piece, the accessory itself, to here. So in this case, we need to have this part, which has a coil or the wires, to be inside here, okay? To be totally inside. So to do this, we need to raise this column, raise it up, then we put inside. Try to not make it touching anything. So in the middle, but it is not touching this one. I hope you can see the scale itself. Scale value. So we are disconnecting the current. Let's press start. So it is 0. But let's start at angle 0 first. So angle 0, the starting is basically the wire should be parallel to the magnetic field. So magnetic field is here. I'm going to change this one until they are parallel. So it's parallel. You can see it's parallel. So the wires are going like this, and the magnetic field as well. It is 0. Let's move this one indicator to become on the 0 angle. Then let's supply with the current. So at 0 angle we have, right now we have 0 grams. Let's move this one with different angles. So 10 degrees, nothing. 20 degrees, still nothing. 30. Okay, so you can see that we have 0.5 grams. Change it. Becomes 0.7. Sorry. You have to turn it on again. Disconnect the current. Turn on the scale. Put the current again. It's 0.8 at this angle at 50 degrees. Then you increase. Comes 70, 90. So it's kind of 0.8 grams. This was the maximum that we have. This go down and see it's 0.6 until it reaches 0 around when the angle is 0. Okay, so this was the fourth part of the lab report. So one, it checked the changing of current and how the force changing, and the second one is about changing the length of the wire itself, then the permanent magnet and how much the magnetic field or the P created. The more magnets, the more strength for the magnetic field. And the last one, the angle between the two magnetic fields and the impact on the force created. I hope you enjoyed the lab for today and you got some useful information. If you like this video, please press like and subscribe to the channel so that you receive the next and future videos. Thank you so much and have a good day.
When currents run the same, they pull each other near.